Picture this. Tonight, while the world sleeps, the largest planet in our solar system simply vanishes. No explosion, no warning, no flash in the sky. One moment Jupiter is there, hanging in the darkness nearly 500 million miles away, and the next moment, it is gone. At first, nobody on Earth would notice. The oceans would not rise, the ground would not shake, the sun would still rise in the morning. Cars would move, cities would hum, and life would go on as if nothing had happened. But far beyond the orbit of Mars, the architecture of the solar system would have just been changed in one of the most dramatic ways imaginable. Because Jupiter is not just another planet. Jupiter is the giant of giants. More massive than all the other planets combined, it dominates the outer solar system with a gravitational reach so vast that it influences asteroids, comets, moons, rings, and even the long-term stability of planetary orbits. Remove Jupiter, and you do not simply erase a world. You remove one of the main pillars holding up the structure of our cosmic neighborhood. So what would really happen if Jupiter disappeared tonight? Would Earth be safe? Would the asteroid belt collapse? Would Saturn take over? Could life on our planet survive the long-term consequences? The answers are stranger, slower, and in some ways more terrifying than most people expect. Because the danger would not come as a sudden blast of destruction. It would come as a chain reaction unfolding across years, centuries, and millions of years, gradually reshaping the solar system we depend on. Tonight, on Infinite Science, we are exploring what happens when the solar system loses its largest guardian. To understand the consequences, we first need to understand what Jupiter really does. Jupiter is the fifth planet from the Sun and by far the largest. More than 1,300 Earths could fit inside it. Its mass is so great that if you combined every other planet in the solar system, Jupiter would still outweigh them all. It is a gas giant made mostly of hydrogen and helium, with crushing pressures, immense storms, and a magnetic field so powerful it would be deadly to humans long before they ever reached the planet itself. But Jupiter's true importance is not just its size, it is its gravity. Everything in the solar system is engaged in a gravitational dance. The Sun dominates, of course, but Jupiter is the next most powerful player. It tugs on asteroids in the asteroid belt, shapes the paths of comets entering from deep space, influences the orbits of neighboring planets, and acts like a giant traffic controller in the outer solar system. In some cases, Jupiter protects Earth. In other cases, it can actually send dangerous objects our way. That is why scientists sometimes describe Jupiter not as a simple shield, but as both a guardian and a troublemaker. Its gravity can fling objects away from the inner solar system, but it can also redirect others inward. So if Jupiter vanished, the first thing to understand is that the change would not travel instantly. Gravity moves at the speed of light. Jupiter is far from Earth, which means we would continue feeling its gravitational influence for about 43 minutes after it disappeared. For those final 43 minutes, nothing would seem different anywhere in the solar system. Then, at the speed of light, the news would arrive physically. Jupiter's pull would be gone. Its moons would feel it first. Jupiter has dozens of moons, including the famous Galilean moons, Io, Europa, Ganymede, and Callisto. These are not tiny rocks. Ganymede is larger than Mercury. Europa may hide a global ocean beneath its icy shell. Io is the most volcanically active world in the solar system, heated by gravitational stress caused largely by Jupiter. The instant Jupiter's gravity vanished, these moons would no longer be moons at all. They would continue moving through space at the speeds they already had, but instead of orbiting Jupiter, they would fly off on their own independent paths around the Sun. Some might settle into stable solar orbits. Others could be perturbed over time by Saturn or by one another. The entire Jovian system would be shattered in a single moment. Io would change dramatically. Without Jupiter constantly flexing it through tidal forces, its internal heating would drop. Its relentless volcanism would likely decline. Europa might also cool internally over immense stretches of time. Worlds that once seemed active and dynamic would begin a slow transformation, simply because their central anchor was gone. Then there is the asteroid belt. Many people imagine the asteroid belt as a crowded field of constantly colliding rocks. In reality, it is mostly empty space, but Jupiter plays a huge role in shaping it. Certain regions of the asteroid belt are nearly cleared out because of orbital resonances with Jupiter. These are called Kirkwood gaps, places where Jupiter's repeated gravitational tug destabilizes asteroid orbits. If Jupiter vanished, those resonances would vanish too. Over very long periods, the structure of the asteroid belt would begin to change. Some previously unstable regions might become more stable. Other asteroids, no longer guided or disturbed in the same way, could drift into new patterns. This would not create instant chaos, but it would begin a long reorganization of one of the solar system's most important debris fields. Now let's talk about Earth. Would our orbit change immediately? Only a little. The Sun controls Earth's orbit far more than Jupiter does. If Jupiter disappeared, Earth would continue orbiting the Sun on almost the same path. There would be no sudden plunge into darkness, no dramatic change in seasons overnight, and no immediate threat to human survival. If you were hoping for a Hollywood-style apocalypse by sunrise, this is not it. But that does not mean Earth would be untouched. Jupiter exerts subtle gravitational effects on all the planets, including Earth. Over long timescales, removing Jupiter would slightly alter the balance of the solar system. Tiny changes in orbital interactions can grow over millions of years. Planetary systems are stable, not because nothing changes, but because the changes remain bounded. Take out the most massive planet besides the Sun, and you are rewriting the equations. Mars, Saturn, Uranus, and Neptune would all feel the loss. Saturn especially would become the dominant giant planet of the outer solar system. But Saturn is far less massive than Jupiter. It cannot replace Jupiter's role. The gravitational landscape would be weaker, less controlled, and fundamentally different. One of the biggest questions is whether Earth would face more impacts. This is where the story becomes more complicated. Jupiter is often called Earth's shield because it can capture or deflect comets and asteroids that might otherwise threaten the inner planets. We saw a dramatic example in 1994 when comet Shoemaker-Levy 9 slammed into Jupiter instead of continuing through the solar system. A planet like Jupiter can absorb impacts that might otherwise happen elsewhere. But Jupiter can also send objects inward. Its enormous gravity can redirect distant comets and destabilize smaller bodies, sometimes increasing the impact risk for Earth. So if Jupiter disappeared, some dangers might actually decrease, while others increase. In the short term, not much would change. The asteroid and comet populations do not instantly rearrange themselves. But over thousands to millions of years, the pathways through the solar system would change. Some comet families would become less likely to be thrown inward. Other populations, especially certain asteroids no longer held in familiar resonance patterns, might behave in more unpredictable ways. The most honest answer is not that Earth would instantly become safer or deadlier, it is that Earth would inherit a different kind of long-term risk. The outer solar system would also begin to evolve differently. Jupiter has shaped the architecture of the solar system since its early formation. Some theories suggest Jupiter's necration helped sculpt the inner planets and limited how much material Mars could gather. Without Jupiter in the present, the solar system would not rewind to its youth, but it would begin a future very different from the one we know. Comets from the Kuiper Belt and beyond would travel through a solar system missing one of its largest gravitational gatekeepers. Some would pass through regions once dominated by Jupiter, with much less deflection. Others that might once have been thrown out of the solar system could linger longer. The entire traffic pattern of icy bodies would slowly change. There is also a deeper consequence: stability. Our solar system appears stable on human timescales, but gravitational systems are delicate over immense spans of time. Small forces add up. Tiny orbital shifts accumulate. Computer simulations show that the planets can remain stable for billions of years, but that stability depends on the exact arrangement of masses and orbits. Remove Jupiter, and you remove a major stabilizing and destabilizing force at once. That may sound contradictory, but it is true. Jupiter both perturbs and helps organize the system. Without it, some regions might become calmer, while the larger planetary system may become less predictable over deep time. Could a planet eventually be ejected? Could orbital resonances form between different planets that did not matter before? Could Mars or Earth experience larger swings in eccentricity, changing the shape of their orbits and therefore climate over geological timescales? Possibly. Not tomorrow, not next year, but over millions of years, the answer could be yes. And that may be the most unsettling part of this entire scenario. Jupiter's disappearance would not likely kill us right away. Instead, it would create a solar system that becomes less familiar the longer it exists. There would also be scientific shock on Earth unlike anything in history. Within minutes of the gravitational delay ending, observatories would confirm the impossible. Jupiter was gone. Its light would vanish from telescopes after the same 43-minute delay. The world's scientists would scramble to rule out error, instrument failure, sabotage, and every other explanation. But soon, the truth would become unavoidable. A planet had disappeared. This would not just be an astronomical event, it would be a philosophical crisis. Jupiter has existed for the entirety of recorded human history. Ancient civilizations tracked it in the night sky. It shaped mythology, religion, navigation, and astronomy itself. To see such an enormous object vanish would force humanity to confront a terrifying reality. The solar system is not as permanent as it seems. Space agencies would likely redirect missions and telescopes to study the aftermath. The former moons of Jupiter would become some of the most important objects in the sky. Their new solar trajectories would be tracked constantly. Some might become targets for future probes. Imagine a mission to Europa, no longer entering the realm of Jupiter, but chasing a free-floating ocean world, now orbiting the Sun alone. And what about the night sky? Jupiter is one of the brightest objects visible from Earth. Its disappearance would be noticeable to anyone familiar with the sky. That bright, wandering light, seen by generations, would simply be gone. Amateur astronomers would feel the loss emotionally, as well as scientifically. One of the solar system's great landmarks would have vanished. There is another question people rarely ask. What would happen to the Sun? Almost nothing. Jupiter is massive compared with the other planets, but tiny compared with the Sun. The Sun contains more than 99.8% of the solar system's mass, so losing Jupiter would not meaningfully affect the Sun's energy output or structure. The center still holds. That fact is both comforting and humbling. It reminds us that the solar system is hierarchical. The Sun rules all. Yet within that hierarchy, Jupiter still matters enormously because of how it shapes everything beneath the Sun's dominance. If humans somehow survived for millions of years in a Jupiterless solar system, our descendants might live under a sky and within a planetary system subtly different from ours. Different impact histories, different comet patterns, different orbital cycles. Perhaps a more chaotic deep future. And all because one planet disappeared. This thought experiment reveals something important about our place in the universe. We tend to think of planets as isolated destinations, each one interesting on its own. But the truth is that planets are part of a connected system. Remove one major world, and you do not create one absence. You create a cascade.
Jupiter is not important only because it is large or beautiful. It is important because it helps define what the solar system is. It shapes pathways, sculpts structure, stirs debris, controls moons, and influences futures we may never live long enough to see.
So what if Jupiter disappeared tonight? Tonight, Earth would survive. Tomorrow, the Sun would still rise. Next year, human civilization would still be here. staring upward in disbelief.
But the solar system would no longer be the one that gave birth to us. It would be a changed system, missing one of its foundational worlds, beginning a long and silent transformation that no human generation could ever fully witness from start to finish.
That is the strange truth of cosmic catastrophe. Sometimes the most powerful disasters do not arrive as explosions. Sometimes they arrive as absences. A missing planet, a broken balance, a future rewritten by gravity.
And maybe that is why Jupiter matters so much. Not because we live on it, not because we could ever walk on it, but because even from hundreds of millions of miles away, it quietly helps shape the conditions that make our world possible.
The universe is full of spectacular violence, but it is also full of invisible order. Forces acting across vast distances, relationships between worlds, hidden balances that hold for billions of years, until suddenly, in our imagination, or perhaps one day in reality, something changes. If you enjoyed this journey through one of the most unsettling what-if scenarios in astronomy, subscribe to Infinite Science. Because the universe is not just a collection of strange objects, it is a system of deep connections, and every question we ask reveals how fragile and extraordinary our place in it really is. And the next time you see Jupiter shining in the night sky, remember this: that distant giant is not just another point of light. It is one of the great architects of our solar system. And if it were gone, everything after us would inherit a different universe.